Yes, the mythical Alma Build System. All right, here we go. Hello there. As we like to usually start, we are AlmaLinux. I'm Jack. Obviously, I guess I'll let everyone introduce themselves. So, guys, why don't you go ahead? I think this is the first time a few of you are presenting here. So,
Okay, I will go first. My name is Vasily, and I'm a team lead for engineering team behind the AlmaLinux Build System. So yeah, basically distributing tasks for people and making sure we are doing the right thing. Thanks.
My name is Andrew, and I'm AlmaLinux architect, and I'm responsible for all the packaging stuff, on the ISO stuff. My team also do cloud images, Docker images, so on, and so on. So I am the main user of AlmaLinux build system now.
My name is Vyacheslav, and I am a Python developer. I am a main developer of AlmaLinux Build System.
all right, and thanks everyone for joining us. So, of course, we want to start out by thanking all the foundation members and sponsors. All the support really helps us do everything that we've been able to do from day one. So, thank you, everyone. If you know them, if you don't know them, get to know them. Thank you so much. So, what is the AlmaLinux build system? So, obviously, it's a system to automate the process of building, testing, signing, and releasing packages, and the AlmaLinux distribution itself. It's really geared for automation and minimizing human error in that whole process. The foundation of the build system started with the Cloud Linux building automation system, which was a project that was started in 2012. Obviously, this is a lot more intricate than that, but some of the concepts that were used there kind of carried over into this. And then, of course, we integrate with Jenkins to extend a lot of the functionality in the system. So many of you may be asking, why not Koji? Well, obviously, because we have loads of free time on our hands and figured there would be no better way to spend that time than putting together our own build system. So there was that. And then we also wanted to facilitate learning. The process of putting together a distribution is a complex one. And we felt like, doing this would help a lot of people learn a lot about that process, and hopefully will allow the community to learn a lot about this process too, as different parts of the build system are opened up and made available to them. We also wanted to support additional package formats, so not just RPMs. We also wanted to provide a single integrated pipeline for distribution maintenance. So the building, the testing, the sign, the release, just to have that all under one umbrella in one pipeline. And really just something to manage that whole chain from end to end. How does it work? So I guess Vasily or Slava, you guys want to talk a little bit about this one?
Yeah, I can take it from here.
Sure.
Okay, so basically it all starts with upstream Git repository, which we then pull into our Git repos with a little magic on it. After that, we start to actually producing packages out of our Gits. So this schema looks a bit scary actually and big, but it's come down to pretty simple things like master service is actually just a simple, maybe even small web server backend, which just handles all of user requests, UI and stuff, and so on. build nodes handles all of the things like all of the mock stuff and so all of actually producing packages out of source repos. So after we got our RPM packages, our build nodes applied in them to our artifact storage, we are using previously on previous iteration of this project, we was using just raw file system and some of our own stuff. But with AlmaLinux Build System, we decided to move to pulp, since it's kind of mature and is handling our needs more.
Basically, it's a good artifact storage, and it allows us to expand further to if we will want to go to deb packages, to even building containers and so on. Pulp has us covered because it has different plugins inside, and yeah, it fits our needs pretty good.
Yeah, it's also allow us to remove a lot of boilerplate, a lot of bugs, a lot of stuff. I mean, I can't even remember what I hit a single issue with Pulp. So Pulp really helps us to build things faster. After package is producing, it comes down to the test system, which is kind of sophisticated stuff going on here. It's decide to test it on real machine if it's some sort of special package which require like real kernel and stuff, or we can use Docker for test. After that, all of the test logs and results comes to our main service and our pulp. We are not using pulp only for like RPM packages and stuff. We're also using it for logs, so it's kind of great. We can reuse this thing for everything. If everything is fine and package is built and tested and everything is fine, so we move it to we actually sign it, so everyone could understand that this is package produced by us. Is this little thing called sign server. Signed packages also comes down to pulp, so it's yeah. And after that we have we just actually sync in our pulp repositories to our mirrors and stuff. So yeah, to our clients. I think that's probably it.
Yeah, so I'm going to walk through a little bit more of the details of some of those pieces. So we use Gitty for the sources, and that's at git.almalinux.org. We also put together a listener which watches for the updates on the CentOS Git repository. And then whenever there is an update, it basically queues the data via MQTT, and then the master service, which is really kind of like the brain behind what's going on, subscribes to the queue, and then when it sees that another message has come in, it figures out what to do with that message, basically, which could be one of a couple different things. So this is the master service. Basically, without getting into too much detail, it interacts with everything via API. And that makes it very extensible, which is great. It can create a build depending on the message. It can restart a build, delete a build, and it takes the task basically based on the message from the queue, and then sends it out to the build nodes. and tells the build node to build. Once the build node builds, it'll send it another message back, and then it'll send it to the test system, and then after the test system passes everything, it'll send it another message back, and then the package will get moved on to the signing nodes, and then it'll get released into the repo. So this really allows maintaining platforms for builds. Like, you can add a new platform with new architectures also. It's all very kind of streamlined. We also have multi-lib support via Beholder. We have no-arch support, so that if you're building a no-arch package, it's not going to get rebuilt for all the arches that you build. And you can take a look at the API docs to see like the full set of functionality for the master service on GitHub. So what's the tech stack behind the master service? We're using Postgres for the database. We're using Pulp for the artifact storage, like was mentioned a few times already. We use Redis as a storage source for repo info and front-end info cache. We use Nginx for the web front-end. Docker's part of that. Python 3.9, Fast API, which is a REST API framework. SQL Alchemy, and Alembic. So the build nodes, like was mentioned, and again, I put a lot of the links in here because I want to make sure that people have the ability to go in and see all the code. So the build nodes basically receive a build task from the via the queue from the master, and then it'll commit the package back to artifact storage. Once the build is done, hopefully the build goes through properly. It supports multi-arch as well. You can build from a specific tag or a specific branch too. And so the build tasks, the artifacts, the packages, the logs, basically everything gets stored in Pulp. Like Pulp is, if the master service is like the brain, Pulp is the heart or the stomach of all this stuff. And it can handle multiple builds simultaneously. That's configurable based on, what the underlying resources of your system are. Then we have the test system. So the test system is actually very robust. Like Slava said, like it can do a bunch of things. So it's built to be like a real system for real circumstances. It can launch a bunch of tests. You can specify like the test runner type, the distro name, all the stuff that I have on the slide here. It basically calculates like where to send the task. And then we have Celery, which is like the task manager, listens to the queue. We also use Terraform to manage the test environment. So like we mentioned, if it needs a real machine, it'll get a real machine to test on. If it needs a container, it'll be tested with a container. If it needs a VM, it'll get tested in a VM. And then all the artifacts and also the task results are stored back in Pulp. So we have all that documented, and all of it is transparent. And anyone that's doing any of the work can obviously take a look at any of that stuff and see what happened. And then it'll return the status and results via a separate endpoint. And then things move on to the signing server. So the signing server is really kind of basic. It sends like a request for work to the master service, and it'll get back a signing task, like saying, hey, here's a package for you to sign. It downloads the package from the artifact storage, and then it'll check the PGP key for validity each time it signs the package. So the Alma keys, it verifies them every time. And then it'll sign the file, and then it'll upload the signed file back into Pulp. And it updates the status, obviously, in the queue. So that's like the 30,000-foot overview. And then I think Vasily is going to do like a little demo of how the system actually works and what you can do with it. So Vasily, I will stop sharing and I'll let you share.
Okay. So let me share our build system UI. So as you can see, now we have a read-only view for everyone to come and check what we have, what we've built, and so on. You can go into each build, see the artifacts, see the status for signing, whether it's secure boot build or not. By the way, we have support for signing via secure boot certificates. So as you can see, we have a list of artifacts for each architecture we've built. We also show from which reference it was built. And we have a list of repositories related to each architecture plus source. And sorry, one sec. I will probably just share the whole. Yeah. As you can see, Pulp provides a way to see the actual repositories in pretty straightforward way. So yeah, you have all the logs, you have ability to check what was going on, what was the config for building this package, what were the logs, and what are the test logs. Unfortunately, they are still running, so nothing there right now. You can also download the log, and you can also download the package itself. For example, let's do this, and the package will be downloaded. You can check the contents on your machine. So to build something, you need to log in. For now, we have only GitHub login, but in the future, we will support different social logins. As you can see, the interface now has additional buttons, like you can check what were released. You can create a new release. You can create it's called a new distribution, but basically it's a set of repositories where you can put a few builds and reuse them as a single entity. And for the builds, we have an ability to build both packages and modulars. So the system comes with the modularity support. You can select a platform, and then you can select what architectures you will be building for. In my case, I will select 2, for example. We have additional flavors like we can enable YAPL repositories for our build, or we have also the beta flavor for AlmaLinux 8. We have ability to set different mock options for the build and set whether it will be a secure boot build. Then you come to project selections. What is project selection is basically all the packages we have in Git source manager. So for example, I will try to build something like grub. I pick the package, and then I have all the references for it. I will be building from the branch, for example, this one. And then I submit. I have the item put to the scheduler. I also can change the mock options for the project. And then I just create a build. It will not be instantly on the screen because creating a build is a bit intricate process because we need to create different repositories and so on. It takes a lot of time, and just to ensure that everything will be working fine, we've decided to have background tasks for long operations. They're working using Traumatic instrumentary. So if you will refresh the page, you see that build is started. And for modularities, for example, let's pick the same AlmaLinux 8 and one architecture. It's the same interface, but you have this toggle, which now we have modulus, and if we are picking up something, it's modulus, not packages. So for example, let's pick Nginx. The same selection for references. And now I will try to build something like that. And as you can see, we have already Nginx built for our distribution, but we can override this. So we can just press plus button, and this will mean that we want to build package, build module, even if it's already built. We have a preview for modulus YAML file in our interface, and we also can set different mock options for the module. And well, when we're done with all the settings, we just create a build and wait until it will pop up in the interface. So that's basically it. Pretty straightforward, easy to use, and provides quite a bit of flexibility in terms of what you will be able to build. Also, I've showed only when we use Gitya, but you can basically build from either from SRPM URL you provide here, or you can build basically from any public repository on the internet. You just put its URL and the reference from which you will be building it, and it will also be picked up by the system. So that's pretty much it.
Awesome. So let me share again, and then we'll just talk a little bit about the roadmap. So what is our roadmap? So for July timeframe, we'd like to finish implementing the role-based access control and grant access to maintainers and contributors from different orgs. We think that's very important for the community to have that capability and to be able to use the system as well. So we don't want it to be something that's used exclusively by us. Also, one thing that we're trying to do is integrate software bill of materials support via Code Notary. So basically have attestation and provenance for everything that runs through the build system, which will eventually become a federal requirement and maybe even beyond the United States, but certainly it's becoming like a best practice for security. So we want to make sure that we have that as well. And then for the future, we want to set up organizations and SIG namespaces. We also want to provide support for Copper repos. And one of the most important things I think is also to automate VM and container image builds, because it would make Bala, who's saying hi in the chat right now, it would make his life much easier, because right now a lot of that needs to be triggered manually, and just automating that would make things a lot easier for everyone and just reduce the release time. So what you can do to help, join us, of course. I can't say enough about that. No matter what you do, we can use your help. Obviously, DevOps for sure, cloud stuff, HPC, security. If anyone wants to write docs, I will love you forever. Our site, our wiki. We have our community chat, which is bridged to IRC, which is the most happening place on earth. All our sources for everything is on GitHub and git.almalinux.org. Also, check out Elevate. We're actually looking into doing 8 to 9 right now, so we could use help with that. And probably the most important thing is become a member of the foundation if you care about the project. It's totally free for anyone to become a member. And we've actually just been discussing like time frame for elections for the fall. So I'd like to give everyone a chance and make sure that everyone has a chance to make sure their voice is heard. So I think that's it for us for now. These are some resources that you can use if you need to reach us or want to get involved. And thanks, everybody. And Sean, I believe that's your cue. If anyone has any Q&A, we can continue in here. I believe Sean may want us to take it into the hallway track. Now you can.
Thanks. Yeah, so like there's a participant limit in Hopin, and it's by default set to 5, and apparently the presentation counts as a separate participant. So anyway, are there any questions? I don't see anything in the Q&A, and I think you guys addressed everything that came up in the chat. If not, I think we're right at time anyway. So our next talk will be in 15 minutes at 1:30. So thanks all 4 of you for this great presentation, and I'll see you all on the hallway track.
Thanks, everyone.
Thanks.
Bye.
Bye.